Welcome back everyone to another video in our pipe stress analysis course. In this video, I'm going to show you how to model a rigid support in your system. There are many types of rigid supports, as we explained in section 1, depending on which direction it is restricting the movement. First one we are going to add is anchor support. Let's go here to this element. We are going to insert our anchor support at the start node, which is node 10. We are going to select this element. It is from 10 to 20 and we are going to press at this restraint. Once you press on this restraint, it is going to open for you this restraint tab. It is asking you about which node. Is it going to be node 10 or node 20, the start or the end? We will keep node 10. And what is the type? We will select anchor. And what is the gap? Is there any gap between your element and between the anchor? We're going to select 0. This is the stiffness. If it has a specific stiffness, if you kept it empty, it is going to be infinity, which means it is totally stiff support. And this is the friction coefficient. This friction coefficient, it depends on the material between your pipe and this support. But this is mainly you are going to use it in guide support, as I'm going to show you in the other types. But here in the anchor, it is going to be fixed anyway, so it doesn't matter. Let's insert it as 0.3. And this tag, of course, if you want to mention a specific name for this support, for example, if this is anchor support, anchor number 1, for example, if you are going to name your support through the system. So this is our first support. This is it. Now I want to insert another support here at 0.20. I can either do it from here and select 0.20, or I can do to this one, and again I'm going to do the same. Select restrain. Is it 30 or 20? I'm going to select 20. Now you can see here all of these supports are rigid supports, but with different restraining forces. Here, if we selected this X, let's press here. This is this represents a limiter because it prevents the movement in the X direction, which is the longitudinal direction of the pipeline, but it doesn't prevent any movement in Z direction or Y direction. If you selected Y, press enter, you can see this is a vertical support in both directions, X positive, X negative. Sorry, it's Y positive, and Y negative. If you selected Z, it's going to be the same in both Z, positive and negative. And you can select also in a specific direction only, for example, only X positive. So you can see it is only in this direction, but it doesn't prevent movement in the other direction. The same if we selected Y positive, for example. This is a vertical support. It's only vertical, so it doesn't prevent the movement to up. It only prevents movement down because it has only a vertical reaction in Y positive direction. This is like a rest support. The pipe is only resting on this one. But if you selected the Y, it prevents in both directions. This means it is a vertical support with clamp. You have a steel clamp here. It prevents movement in upward or downward. You can select a guide support. So you have many types. It depends on your actual support at the site. Let's select guide support, for example. Here the gap is going to be very important, because here actually you are going to have a specific gap. Your support, there is no way it is going to be 100% in contact with the pipe. Of course, there will be insulation between both of them, so there is a specific gap between the support and the pipeline. It is going to be a small value, but it makes a huge difference in your calculation. So you need to get this value from the insulation material or the cladding around the pipeline, and between the support also there is there will be rubber or some kind of insulation around your support. You need to calculate this length or this thickness, and you need to insert it here as a gap. Let's assume that we have, for example, 2 millimeter gap, for example. We insert it here. You can see now that your support is not directly in contact with the pipeline. It has this specific gap, which means that your pipe will be free to move in this direction with only this specific amount. It has only 2 millimeter freedom to move in the X direction, or sorry, this one is in the Z direction. It is very important to represent our boundary conditions as accurate as possible, because this will give us an accurate results, an accurate analysis. Here, the stiffness, as we explained, you can keep it blank because this is not, it is a stiff support. And here's the friction. It is very important. Here you have to insert the exact friction coefficient between the insulation material and between the support and between the insulation of the pipeline, or directly between the support and the pipe if there is no insulation. Because here, let's assume that we selected, for example, a Y support, a vertical support. Here it is. Now, if you didn't insert any friction here, if you kept it 0, for example, this support, it doesn't prevent movement in this direction. This is both correct and wrong at the same time. It is correct because this support actually it is designed to prevent mainly movement in the vertical direction, but it is wrong because the weight of the pipeline and the friction between this weight and this support, it will create some kind of limitation of movement in the longitudinal direction. This limitation, the value of it equals the weight of the pipeline multiplied by the coefficient friction between the pipe and this support. So which means that your pipe is free to move, but actually there is a small resistance here, small resistance in the longitudinal direction. The value of this resistance, it depends on the weight, which is going to be calculated by the software multiplied by the coefficient of friction. So you need to insert an accurate coefficient of friction between both these surfaces, either the insulation and the support, or the pipe and the support, depending on the material of both this support and this pipeline. So let's keep it as 0.3, for example. Now let's insert another one here at 0.30. It is going to be the same. I'm going to insert a support in Z direction this time, and it's going to be the same. Let's assume 3 millimeter gap. It is moving, and 0.3 coefficient of friction. So this is it in summary. Of course, here I can also give the tag name of the support, like I did to this one, to the anchor, and this one. Right now I'm inserting these supports just randomly, and I did it in purpose to put some inaccurate location of supports, because we want to get this errors after we run the analysis, and we will see how to fix this one in our third section. So this is it for our video today. Thank you.